26. I have to remember how to count. You do some high-level mathematics with our calculus, we forget how to count afterwards. Okay. Evaluate, check by differentiating. Now, hopefully you can remember. They don't tell us integration by parts, but that's really all we can do because x squared is not the derivative of the natural log. If this was natural log x cubed, that would go down and then it would be, a derivative of the inside, but it's not. So natural log, what we're going to do is integration by parts here. It doesn't say, but that's the only way to do this, because one part is not the derivative of the other. Okay, using the chain rule. So remember, our integration by parts starts out with u dv, so two parts, and then the formula is equal to uv, or last time, if you watch my other video, I do vu because uv is easier to remember for me. And then we get the integral of, we don't keep integrating u, what we do is we get v, so we're going to integrate one part and then we're going to integrate it again, du. Okay, so it's kind of like, to do this we take the derivative of u and then we're going to integrate it, sort of. So we'll see how this works. So now the big thing is choosing our pieces. Again, we want to find something where we take its derivative, we get something that goes away, and that when we integrate doesn't get too much worse. Now, usually, like in the last one, the part that had the x squared, we don't want to integrate that because that's going to become x to the third. However, natural log of x, there's no easy way to integrate it. In fact, actually, they use integration by parts to integrate natural log of x. But remember, natural log of x, when you take its derivative, you get 1 over x. So at least the natural log part is done. And then when we put our pieces together, this x is going to cancel out with the x that we're going to get from integrating. So this is a slight change. When we had e to the x, we would let that be the part that gets integrated, so the dv part. And then we would have let u be equal to x squared and go through. But with natural log, it's different. We want to make the natural log our u, and then our dv is going to be x squared dx. Okay, and then we set up our little box. And again, I mentioned it in the last video, but you might not have watched that one. Maybe you're watching this one because it's more complicated. But I do have a integration by parts video in here under the other MAT210 playlist. I can't remember what section it is. That's one thing I have to work on, is my organization by content rather than by sections, because as we change text and everything, that all changes. However, at the same time, I'm not really making these videos for perpetuity. I'm making them for you this semester. If they're helpful for other semesters, that's great, but otherwise these are really designed as single use. So du, I just copy it, and notice it's going to end up here but not here, so we're done with it. Then I take its derivative. Derivative of natural log of x is 1 over x dx. Okay. This side, I come down here, what I'm going to do is I'm going to integrate it. And so I add 1 to the exponent. I get x to the third, and then I have to divide by that. Now it is getting a little bit worse, but you're going to see we're going to be okay. It's really going to be okay. So this is now, what is this? We integrated with basically respect to v. This is our v. Okay, this is our u. This is our du part. And so this is just going to be, notice v gets top billing, it gets to go in both places. We just copy it down here. And why do we do this? Because then we go straight across the boxes to get our pieces. So the first piece comes from u times v, so that's going to be x to the third over, we'll just make a big fraction, over 3 natural log of x. And that part is now done, right? It's been integrated, it's out here, that's where it goes. This part we multiply straight across, and we're going to get x to the third over 3, and then we have the 1x, 1 up in the numerator, x down here, dx. So you see that x to, while we did get an x to the third, this little x cancels out and we get an x squared again. It's not too bad. So let's put our pieces together. Vu is right here. So this is v times u, and this is our v du. So we get x to the third natural log of x over 3. Beautiful. And let's see, we got this minus v du, so that's this part here, and we're going to simplify it. So x to the third, these guys cancel, so we're going to have the integral of x squared over 3 dx. Now we're not quite done, we still have one more integration to go, but this is a nice, as we'll say, simple integral. No more needing to use parts or anything. We can directly integrate this. So again, we'll put our plus a constant at the very end. Or maybe you'll just say, okay, remember, I'm going to have a plus a constant. Okay. Maybe from the first part. So let's come here. So again, we're just copying. That part is done. This part we're going to integrate. Again, just doing our standard, add 1 to the exponent, then divide by that exponent. So that's going to give us x to the third divided by 3 times 3, right? I could move that out front, but we didn't. Sometimes we do it, sometimes we don't. I think consistency is highly overrated. They say variety is a spice of life. So, and actually for me, and again, we're all different, but for me, I need that variety. I need to see, and it helps me because I can see things backwards and forwards. But that's the way I think. They call it dyslexia, but Einstein, he had it, and it was they called it disassociative thinking, and that's what allowed him to get these great ideas he had about the universe that ended up nobody else had those. It was true. What he says is true, or true at a level. I don't know if anything's exactly always true, except for morality. You should always treat others with great respect and kindness. That's the one rule that is the same in every universe, every world. And if you don't, well, it comes back to you, because everybody wants the good stuff for themselves. And when you do bad to other people, they'll remember. They'll get you. Karma will get you. So be good. It's its own reward. What does that have to do with math? I don't know. But anyway, thanks for listening. Good luck on the forward progress. We'll get to 27 next. Thanks.